Yeah, today's video we gonna learn the not the typical way of seeing differentiation, but we'll see that how the differentiation actually works. So if you might have seen about this particular way, the thing ddx of certain function result into a certain function, then we say that ddx of that particular function is gx. But the question is that how actually it works, how we are what we are actually doing here. That's the main question. When what we are trying to do here and what we are trying to achieve here, that's the main thing. Yeah, so just keep that one thing in mind. That would be very clear to you. If we write dy by dx, it is actually what we are trying to do here is we are changing in the y. That means something like, if you see d, take d and dx. Maybe you can say there are some cases of changing in y, changing in x, and taking their difference, something like that. It is the case. You can say it's not exactly equals to like that, but maybe for a very small difference, if I'm taking difference between 2 points and dividing it, it could look something like this. Just imagine that, suppose that you have some, in a particular situation you have some graph here. Just see that. So if I take this point as a x1 y1 and this point as a x2 y2, here y2 is 0. But just see that if I take the difference between the x points of these 2 points, if I just see that here, and x by fortunately the 2 points over here. No, let's make it little more complicated. Take the point like this over here. Yeah, this would be more clear to you. If I take this as a x2 comma y2, if I just want to take the difference of these particular thing, like if I do just like this, y2 minus y1 divided by x2 minus x1. If you take the actual, what I'm doing here is, if you take the x2 minus x1 difference, it could be something like this. Now here, the whatever the value of x1 minus x2 in terms of positive value, if I take, this would be the difference. In terms of y, if you try to draw it here, it would be something like this. Maybe y1 minus y1 minus y2, this would be the difference. So if I just draw that particular thing, it could be like a triangle over here. This is the x difference, this is the y difference, irrespective of the negative positive value. This is the x difference and y difference it would be. And we know that in tan, if we take a theta over here, we can write tan theta is equals to y by x, the difference of y and x. So this thing that you need to keep in mind, that will take use of those things and all. So whenever we write d of dx of certain function, we can, you might know that we can write it something like limit h, if the difference, if the function is differentiable, that is a difference case. We are assuming that all the function we are taking is differentiable for a moment. So that is the thing we can write either in a positive way, either in a negative way. I'm just taking a very small, we can write it on a, we are taking a very small change in function value. Yeah, we are just checking that how, if I ask you, oh, suppose that just to take a simple example over here, if I say at a particular time 5, distance covered by a particular person was 10. At a time 10, the distance covered by a particular person was 30. Yeah. So you tell that, if I ask you the speed, you will say 30 minus 10 divided by 10 minus 5. You could say something like 20 divided by 5. That is like a, you can say here the particular person was walking with the speed of 4, whatever the unit was, unit per second. Yeah, I suppose that that time was in second. So depends on the particular situation. It was working like that. So it is. This is the same concept we gonna do, but the difference gonna right now here. If you see, the difference was 10 and 30, but we gonna take a very small difference. That is why the h means here. That means h is very small. Just keep that in mind. Very small difference in the function, and we want to check that. is that particular, where that particular value is leading, what is the actual rate of change of that particular function. So if I talk about this particular, let's take an example of sine x. It's an interesting case. We know that maybe the formula, you know that when you do the differentiation of sine x, it leads to cos x. That means if you ask the meaning of it, the simple na, the rate of change of sine x is cos x. It's an interesting thing to note it down. So yeah, just see that when I do this difference, if I take the difference of sine x, if I write it, if you write it out something like that, sine x and all the formula, if you try to write and less tends to 0, all those things you write sine x plus then you do the expansion of it, then you write all those things of it, and it comes as a cos x. That is a simple derivation, you can do that. But let's see that by graphical visual how it actually looks. If I draw the graph of sine x, if you see, it could look something like this. Yeah, let's come to the interesting part here. Yeah, if I differentiate it as a x at equals to x equals to pi, with that we know that here, what does that mean? That means I have to move a bit from x. That means x, maybe I can write in, if I take h tends to 0, then I have to move a very small distance over here from x to x plus, sorry, I can say x equals to pi to 2 pi by 2 plus h. This is a small distance I have to move in the x direction, in the same that I have to move in the function direction as well. That means in the direction of f pi by 2. Here function is sine x, so that we have to keep that in mind, and I have to take the difference of this particular with the difference of this particular value, that is f pi by 2 plus h. Yeah, so I told you that the differentiation we have to do is a very small difference. So can I write it something like f x plus h? The same thing, I will replace x with the pi by 2, and the difference was pi by 2 plus h minus pi by 2. The same thing I told you now, but the only point is that here difference we have to mention is very small, very small. So if you do that, the particular thing, if you see that here by value we know that sine pi by 2 is 1. Okay, sine pi by 2 is 1, but difference in value of cos x is 0. Why? If you see that how it is actually happening, if you take the difference of it and solve all those h and all, this particular value comes as a cos x. If you solve this, it will come as a cos pi by 2, that is 0. Why? If you see, the point is that I told you now, this differentiation is actually giving you the rate of change of that particular function. Here if you see the very small difference is there, that means the rate of that particular function at that particular point, if I am changing, look, if you see this slope over here, let me draw it properly. If I see this slope and I take a difference over here, very small difference here, maybe for me it's just a very negligible distance, it's a very negligible movement is happening. If I take a very small difference and try to see the difference over here, it's very negligible difference. So that is why if you see, without even seeing that, you can say that this value will definitely would be 0 irrespective of you see cos x or not. If I take a very small difference here and try to see the rate of change of that particular function at this particular, this is the point where the least change is happening with the time, if you take x as a time. But if you see if I ask you where is the maximum change is happening, that is the interesting case for you to see that. If you see this particular point over here, if you see this particular line, if I am just trying it for your understanding, just keep moving this straight line throughout this particular graph. It could be something like, yeah, if you just keep moving this particular line with the graph, you will understand how it is happening. So here if you see the change is happening with the straight line. Here it is having some angle over here, but with the time if you move it over here, the change will come to the angle becomes 0. Then again you move, the angle will become something like this. I can draw that. It will move something like this. Yeah, in that direction it will move. Then again it will go and become a slope over here again. If you see the key, it's keep changing. The point is that the point I wanted to make here is, if you draw this particular one, yeah, for a sin x, if you draw this particular thing, then it will be more clear to you. Here if you try to see that the rate of change of that particular function is maximum. If you see, if I draw it very precisely just for the understanding, if it is at a 0, if I try to check the difference here, if you see the difference is maximum, because it is not a straight, it's completely changing. Even if we are making very small difference, it's changing its rate of change very high. So if you, that is why when we do sin x equals to 0, when we put, yeah, the value is 0. When we put x equals to 0, the value is 0, but the rate of change is maximum here. That is what we want to claim. The rate of change of this particular graph is maximum at x equals to 0. So this is what you have to keep in mind. So this is how a graph of, this is how the differentiation of cos x sin x comes as answer of a cos x. Hopefully this video would have helped you to understand more properly about the differentiation. We'll take more example in the next video and we'll solve that.